Hello and welcome to the session. In this video, we'll discuss problems on linear discriminant analysis. The theory behind linear discriminant analysis has been discussed in the previous video. The link is given in the description box. So the problem is like this. You have to apply LDA for the samples for two classes. Two classes are given here, class W1 and class W2. So these are the data points for class W1. These are the data points for class W2. The first step is you have to find the classes mean. So find the mean for class W1 separately and find the mean for class W2 separately. So to find the mean of class W1, mu1 is the mean of class W1 is equal to 1 by n1 summation of x, where x belongs to W1. So n in this case is 5. Now you are going to add separately the x coordinates of class W1 and divide by 5. Similarly, add separately the coordinates of y. The y coordinates of class W1, add them up together and divide by 5. So the final result you get is 3 is the mean of the x coordinates and 3.8 is the mean of y coordinates. Next, find mu2. Mu2 is 1 by n2 summation of x, where x belongs to class W2. The same process you repeat, the only difference is now these are the data points of class W2. Now add the x coordinate separately, divide by 5. Add the y coordinate separately, divide by 5. So this 8.9 is the mean of x coordinates, 7.6 is the mean of y coordinates. Now step 2 is you have to find the covariance matrix for each class. The covariance matrix you have to find for both classes separately. S1 is a covariance matrix of class W1. So S1 is equal to summation of data points x belongs to W1, because now we are finding the covariance of class W1. So x belongs to W1. You have to x minus mu1 into x minus mu1 transpose divided by n minus 1. So take the data points of class W1, subtract it with the mean that we found here, that class mean mu1. Similar, the same product here, x minus mu1, repeat it, but take the transpose divided by n minus 1. So what do you get? N is nothing but in this case 5. So 1 by 5 minus 1. So this is for the first data point. The first data point is 4, 2. The mean is 3, 3.8. So what you do is 4, 2 minus 3, 3.8 into 4, 2 minus 3, 3.8 transpose. Similarly, repeat plus do for the second data point. 2, 4 minus 3, 3.8. 2, 4 minus 3, 3.8 transpose. Plus again third data point 2, 3, this one, the third data point of x, minus 3, 3.8 into 2, 3 minus 3, 3.8 transpose, plus repeat for the fourth data point, then repeat for the fifth data point. The fifth data point is 4, 4 minus 3, 3.8 into 4, 4 minus 3, 3.8 transpose. How do you do this calculation is first finish this. How do you do this? This is nothing but I will show for the first one. The first one what you get here is 4 minus 3 is 1. 2 minus 3.8 is minus 1.8. Multiply that again with minus 1 minus 1.8 transpose. So if you multiply this, what happens? This will be 1 minus 1.8 into minus 1 minus 1.8. So this is 2 cross 1 matrix. This is 1 cross 2 matrix. What you should get here is a 2 cross 2 matrix. 1 into minus 1 is minus 1. 1 into minus 1.8 is minus 1.8. Minus 1.8 into minus 1 is 1.8. Minus 1.8 into minus 1.8 is, I think it should be 374. I'll just cross check. 1 point. It's 324, I'm sorry. It's 324. So this, like this, you do the matrix multiplication for each one and then add the respective terms. Add the respective terms of all the 5 terms you get. So finally, you should get this as the answer. So this is the covariance matrix of class W1. Now again step 3, repeat, find the covariance matrix for class W2. The same formula. S2 is the covariance matrix of class W2, summation of x belongs to W2. Same thing, x minus mu 2 into x minus mu 2 transpose divided by n minus 1. The difference is now it is mu 2. Now 9, 10 are the first data points subtracted with the means of class W2 8.4, 7.6 into the same thing 9, 10 minus 8.5, 7.8 transpose. Repeat for all the data points. Multiply each term and then add it up together. You get the final covariance matrix. This is for class W2. Any doubts, please let me know in the comment box. Now step 4, you have to find now two things. As we have discussed in the last video, you have to find two things between class scatter matrix and within class scatter matrix. So within the class scatter matrix formula is SW. SW represents within class scatter matrix. It is equal to S1 plus S2. S1 we found out as what? S1 is, we got finally the answer of S1 as this one. This is S1, right? So you add up S1, you add up S2. So that gives me the within class scatter matrix. So this is the within class scatter matrix. Now step 5. Find between class scatter matrix. So the formula is SB is equal to mu1 minus mu2 into mu1 minus mu2 transpose. We found the mu1 and mu2 in the first step, right? So just take that. This is mu1, this is mu2. Again mu1, mu2 transpose. Calculate each of them. 3 minus 8.4 is minus 5.4. 3.8 minus 7.6 is minus 3.8. Similarly, this is again minus 5.4 minus 3.8 because we took the transpose. Now again, when you multiply this with this, you get a 2 cross 2 matrix. This is the answer you get. So this is a between class scatter matrix. Now next step is you have to find the eigenvalues. Now how to find eigenvalues and all we have discussed. Similar concept. Okay. So what we do is to find the eigenvalues. Just remember this. This is a characteristic equation for finding the eigenvalues. What is this? Within class scatter matrix inverse into SB minus lambda I is equal to 0. This is the equation you should remember. This is a characteristic equation. So SW inverses we found out already. This is the SW inverse. And this is SB which we just found here. Minus lambda into identity matrix, you will get this. First you multiply these two. Remember this is inverse. This is not transpose. If you know how to calculate inverse, you do it. Otherwise you do it in the calculator, scientific calculator. So if I find the inverse, I am getting this as a value. So this is the inverse matrix. Inverse of this matrix is this matrix. Multiply this with SB minus lambda into this is a lambda into I, that is the identity matrix. First multiply these two. When you multiply these two and then finally when you subtract by this, this is what you get. Okay. Now you have to find the determinant of this. So how do you find the determinant? Multiply this term with this term minus this term you multiply with this term. So you get this. And when you simplify this equation, you will get this quadratic equation. From this it's easy to find the root. You get, just remove lambda comma. You will get lambda is equal to 0 and lambda is equal to 12.2007. This lambda is nothing but the eigenvalue. So now you found the eigenvalue. Now what you have to do is you have to find the eigenvector. So how do you find the eigenvector? The same thing, SW inverse into SB minus lambda I, the characteristic equation which we used in the previous step. Multiply that with W1, W2 is equal to 0. So basically it's a matrix. So this matrix, you multiply this with the W1, W2 matrix. So when you multiply, right? So basically one thing you have to remember is for W1 is equal to 0. What you do is, what you can do is you keep the lambda as it is. Okay, in this characteristic equation, right? Just multiply these two and keep the lambda as it is. So basically it will be like this. Yeah, you have to write a lambda here, sorry. There is a lambda here. Okay, right? So this is your characteristic equation from this term. And this is W1, W2. Now first time, what is a lambda value? For the first eigenvalue, that is lambda 1 is equal to 0. When you put here 0, when you solve these two matrices, you will get W1 like this. Now how to solve this? We have already done problems on PCA where we have seen two problems like this. Still, if there is any doubt, please let me know. How we can find out eigenvectors from the eigenvalues, please let me know. So you get W1 like this. Next, when I substitute lambda is equal to 12.2007, you get W2 like this. So these two are nothing but the eigenvector. Now which one is the best eigenvector? Normally the eigenvector which has the highest eigenvalue is chosen as the best eigenvector. Now W2, the highest eigenvalue is this. Therefore W2 is the best eigenvector. Now if you are not ready to do all these steps, there's one simple way of finding out W is this. You can remember this equation. That is one more method for finding W is SW inverse into mu1 minus mu2. SW inverse is nothing but this one, right? Within class scatter matrix. So take the inverse of within class scatter matrix which you found in the step 3. Okay, so take that. This is the within class scatter matrix subtracted with mu1 minus mu2. Now one thing is, remember this is inverse, this is not transpose, don't get confused. Okay, find inverse using the respective matrix for calculation, or do it using the scientific calculator. So when you multiply this matrix with this, you will get the final W like this. See, both are same. Either you can do all these methods, or just in one simple method you can do this. So try it, you'll come to know. Now you found the eigenvector. Now this is what? This is nothing but your eigenvector. So now you found your eigenvector. Now let's do the last step. In the last step, you obtain LDA by taking the dot product of the eigenvectors and the original data. See, this is our data points. This is x1 and this is x2. Okay, so this is for class, this until here is class 1, and from here I have class 2. So I have written x and x coordinates and x1 or xy or x1 x2 like this. So for each one I have to find the LDA. So how do you do it is, take the data point, multiply that with the eigenvector which I just found. That's all. Okay, take the data point, multiply with the eigenvector. That will give me this first LDA. Okay, so for each data point you multiply with the eigenvector. Eigenvector I just found out, right, in the previous step. Very easy way of calculating eigenvector. I told you this. Within class matrix into mu1 minus mu2 will give your eigenvector. So take this only directly. Multiply each data point with eigenvector, you will get the LDA. Similarly repeat for the second, 2, 4. Similarly for the third data point. Similarly fourth data point, fifth data point. Like that you continue for class 2 also. So these are all the LDAs which I have written here. So this is your final answer. What you got here is your final answer. So this is your first LDA. Okay, so basically you have reduced the dimensions from 2 dimensions to 1 dimension. Instead of representing it separately as x1 and x2, you are now able to represent in 1 dimension like this. So that's the advantage of LDA. So basically one of the applications of LDA is dimensionality reduction, which is done in this problem. So thank you so much. Any doubt, please write to me in the comment box, and please subscribe to the channel. Thank you.